Good morning, everybody. Today we're going to talk about solving inequalities that are compound. So let's take a look. Two types of compound inequalities are inequalities with and inequalities with or. When we say and, it means both. When we say or, it's with either. And what I'm talking about is this. Here's some examples. If I say the sky is blue and the grass is green, that is a true statement. The sky is blue and the grass is green. If I say the sky is blue and the sky is green, that is a false statement. The sky is not blue and green. It's just blue. All right? If we look over or now, if I say the sky is blue or the sky is green, or could be either one. It only has to satisfy one of the conditions. So if I say the sky is blue or green, yes, it does hold true. That is a true statement. The sky is blue. So yeah, that's the difference between and or. And means both. Have to be satisfied. Or just means one or the other. So let's take a look at a problem so you can see kind of what I'm talking about. So we talk about inequalities. Some people kind of freak out when they see these inequalities. Don't worry about them. They're not too bad. All right. So here's what we do. This is what we call a double T chart, because we got to solve this just like we would any other equation or inequality. So what we're going to do, we're going to put our inequalities, or put our lines through our inequalities, just like we would if it was one or the other side. And then we just solve it like we always do. Okay, we want to get x by itself, right? That's our whole goal. So in order to do that, we have to get rid of the minus 2. How do we undo minus 2? Well, we add 2. Well, then somebody says, well, if I add 2 there, where else do I add 2? Well, we've got 3 columns now, so we have to add it everywhere. So we got 3 columns we're working with. So negative 3 plus 2 is negative 1. We got x in the middle, and 9 and 2 gives me 11. Bring down our symbols, because we didn't multiply or divide by a negative, so we have no reason to flip. And now we just need to simply graph this one. And come on, my eraser's a little slow today. Alright, so I'm going to scroll down on the page just a little bit. Alright, so we graph this just like we always do, except now we have 2 points of interest. Okay, first point is 11. Second point, negative 1. When we're reading this, we always read from the variable. So the easy one to read is the one that goes to the right. X is less than 11. Okay, so that's an open circle because it's not equal to, and it's less than. So if we plug in, I don't know, say 0, is 0 less than 11? That's a true statement. So we're going to head towards 0 on our number line. Alright, pretty easy, not too bad. The second one is a little bit tougher to read. Okay, we read to the left. Alright, this is backwards from, how everybody's taught us to read all these years, but that's okay, because what we can do is we can actually pick it up and flip it. So our variable is on the left side. So I'm just going to put my variable on the left, number on the right, and when we pick it up and flip it, we have to flip the sign as well, so it's greater than or equal to. So since it's greater than or equal to, we got to color this one in, and now we just plug in a number. Use my 0. Is 0 greater than or equal to negative 1? The answer is yes. So we're going towards 0. Because this is an and, okay, we have to satisfy both conditions. In order to do that, it has to be all the numbers in between. Okay, because if it goes outside, we use a different color. So the yellow is in between. Oops, the green highlighter got small. Alright. So the green highlighter indicates where the green circle or my x is greater than negative 1, continues to go outside of my x is less than 11. So any number over 11 doesn't satisfy that piece. Just like my purple highlighter, it's going to show that anywhere outside, or where the red line keeps going, is outside of the green line. Okay, so it satisfies one but not the other. So only the space in between would be considered places for our answers. So basically any number between negative 1 up to but not including 11, because it's not colored in, would be an answer for this particular compound inequality. Alright? Let's take a look at an OR. Switch back over to my calligraphy pen to make myself look fancy when I write. Alright, so I've got 3x minus 1 is greater than 8, or x plus 2 is less than negative 4. So all you need to do in these is simply just look at one piece at a time. So I'm going to use the green marker on this side, and I'll use the blue marker on the other side. And we just do it one by one. They're two separate inequalities, so don't even look at the other one while we're doing the first one. 3x minus 1 is greater than 8. Everybody knows add 1 to both sides. 3x greater than 9. Divide by 3. X is greater than 3. Alright, I think everybody's okay with that and comfortable at this point. X plus 2 is less than negative 4. So we're just going to subtract 2 from both sides. X is less than negative 6. Again, I think everybody's okay with those. Now we need to graph it. So here comes our number line, and just like the AND, we're basically just graphing 2 on the same line. So let's start with the green one. We've got 3. Okay, it's an open circle because it's not equal to, and it's greater than 3. That means we're going to head towards the right. And our blue one is negative 6. That is also an open one because it is not equal to, and that is less than negative 6. So we're heading to the left. Now some people might say, oh, well, these don't overlap. Is that okay? Yeah, that's perfectly fine. If they don't overlap, that just means the spaces in between, whereas before when it was an answer, the spaces in between, now those are the numbers that are not answers. Means everything lower than negative 6 and greater than 3 would be a solution to this because there's an OR. You only have to satisfy one or the other. Make sense? Alright, yeah, that's pretty much it. The only thing you might need to watch out for, let me just give you a couple quick demo. I'm just going to draw the graph just to give you kind of a heads up. Okay, I'm going to say if this is an AND, okay, so I'm not going to tell you what the original inequality was. I'm just going to kind of make this up on the spot here. Okay, so if the point was negative 2 and 4, and say this one was closed, and it went to the left, and this one was open, and it went to the right. Because this is an AND, it has to satisfy both of these. There is no overlapping area. Therefore, there is no solution on this one. Okay? So if you have an AND equation, and it does not overlap, there is no solution. Alright, so keep that in mind. Maybe you want to jot that down in your notes. Alright, let's take a look at this one. This one is going to be an OR. Let's say, we'll keep the negative 2 and the 4 going on. Negative 2. You know what, I don't want to use green. Oops. I want my number line. Let's use black. Alright, so negative 2 is greater than, and let's use red. Open. Okay. If you have an OR that overlaps, and remember, it only has to satisfy one or the other, this turns into all real numbers. Because if they're going over each other, means one's going one way, one's going the other way, we cover everything in the middle. There's not one number you can find that will not work. So that is all real numbers. Alright, so that's pretty much it for compound inequalities. If you have any questions, check your notes, ask a friend or two. If that still doesn't work, come talk to me. I'm Mr. Weeks. Have a great day.